The mangonel catapult is a siege weapon that was used in the Middle Ages. It was used for attacking fortresses, castles, and cities. The word mangonel is from the Latin word meaning an engine of war. It was used extensively by the French and introduced to England in 1216. Mangonels could fire projectiles up to 1,300 feet. It had one arm that was made of timber and a bowl-shaped bucket at the end of the arm. It used ropes attached to the arm to provide force and had wheels to increase maneuverability. The mangonel is an ancient war engine invented by the Romans as early as 400 BC.
The onager catapult got its name from the Roman word for a wild donkey that kicks and bucks, because this catapult would buck when it fired due to recoil. It has a padded buffer in front of its throwing arm to absorb some of the impact. Greeks and Romans used ropes for this catapult made out of horse and human hair. The ballistic catapult is a weapon used in the Middle Ages, similar to a giant crossbow. It works by using tension and torsion power. It is designed to aim huge wooden, iron-clad arrows. This derived from the Greek word ballistas, meaning to throw, and it was invented by the Greeks.
Did you know in 2008 a trebuchet catapult broke the world record for firing distance by firing a pumpkin 1,894.42 feet, according to the Guinness Book of World Records? Catapults threw many types of projectiles historically. For example, catapults threw arrows and beehives and fire and stones and also wooden poles.
Did you know that a catapult can have more than one lever on it, which enables it to throw multiple things at a time? Catapults can also be as small as 1 inch in size.
There are 3 forms of energy involved with catapults: kinetic energy, elastic potential energy, and gravitational potential energy. Kinetic energy is energy possessed by a system or object as a result of its motion. Elastic potential energy is potential energy stored as a result of deformation of an elastic object, such as the stretching of a string. Gravitational potential energy is energy stored in an object as a result of its vertical position or height.
Catapult physics is the use of stored energy to throw a projectile without the use of an explosive. The 3 main energy storage mechanisms are torsion, tension, and gravity. There is potential, kinetic, and elastic energy. An example is when the catapult is launching an object through the air. There is elastic energy in a spring, like material to launch the object. The transfer of energy is from elastic to kinetic. There may be dissipation where some of the energy is wasted due to friction. The gravitational transfer of energy is when the catapult is upright.
Before a catapult is launched and fully pulled back, the catapult is only experiencing elastic potential energy due to the tension created by pulling on the string or elastic material. Once the arm is released, elastic kinetic energy comes in as the arm starts to move, and there's also elastic gravitational energy. As the catapult continues through its motion, the gravitational energy and kinetic energy will start to increase. And after the arm throws, there is no more elastic potential energy because the string is being no more stretched.
Did you know that catapults threw more than just rocks? They also hurled arrows, pots on fire, dead bodies, and dead cattle. This is our beginning sketch that we drew during class. Our actual catapult did not turn out like this at all. The base in this picture would not have held up or would not have been very sturdy. Our inspiration for the throwing arm was a dog tennis ball thrower. We knew it was already designed to hold a tennis ball and to throw it really far. For our string to hold the dog ball thrower back, we were going to use medical tubing, but we decided that a bungee cord would be less expensive and better to use. Also, my dad is an engineer, and after seeing this design, he told us things that we could do differently in order to make it work better.
This is our final sketch for our catapult. It is similar to our first sketch, as we are still using the tennis ball thrower for the arm of the catapult, but many other things are different. We decided to use bungee cord over the surgical tubing. and we drilled holes into the wood around the arm so we could adjust for different angles and test which angle would throw the tennis ball the farthest. We also used metal gusset plates to reinforce the wood of the catapult so it could hold more tension. Did you know the earliest writings of catapults date back to China during the 3rd century BC?
This picture also shows the base of our catapult, which is a lot of wood nailed together that we already had previously for putting up trailers. This also shows the ball throwing arm that we bought at the store, and it already had a hole in the bottom so it could maneuver easily.
At this stage in building, we are trying to determine the best angle for the support panels on the sides of the catapult.
In this picture, we are setting up the table saw so that we can make the wood into the angles that we need.
This picture shows the angles that we cut the wood panels at.
In this picture, we already have one side of the catapult angled, but now we need to do the other side so that it matches and will throw evenly.
In this picture, we are setting up the wood panels that we cut to make sure that they are even.
Right here, we are drilling holes in the catapult in the top and the bottom so that we can put different angles. We are doing this so that we can determine what angles the catapult will throw better on.
In this picture, we are nailing on metal gusset plates to reinforce the structure and the joints.
Right here is a picture of our final catapult. Through a lot of testing, we determined that the furthest it threw was 50 feet. The average was 40 to 45 feet. And did you know that the use of catapults died down around the 14th century with the invention of gunpowder?
This is our works cited page where all of our sources are cited.